Hi all, welcome to new class. Today's class is about conversion of flip-flops. To convert one type of flip-flop into another type, a combination circuit is designed such that if the inputs of the required flip-flop are fed as inputs to the combination circuit and the output of the combination circuit is connected to the inputs of the actual flip-flop, then the output of the actual flip-flop is the output of the required flip-flop. So the conversion of flip-flop is a difficult portion. So here a combinational circuit is designed such that if the input of the required flip-flop are fed as the inputs to the combinational circuit. So there will be a combinational circuit. So the required flip-flop means that is the input, that is the required input. So the input of the required flip-flop inputs are fed as the inputs to the, so this is the inputs to the combinational circuit, and the output of the combinational circuit is connected to the input of the actual flip-flop. So there will be actual flip-flop. So this flip-flop we have to convert to another type. So this is the actual flip-flop and this is the required flip-flop. So this is the input and this input is fed to the input of a combinational circuit and the output of the combinational circuit. So this is the output of combinational circuit and which is connected to the input of the actual flip-flop. Then the output of the actual flip-flop is the output of the required flip-flop. So there will be a combination circuit to convert one flip-flop into another. So this is the actual flip-flop and we have to convert to another flip-flop, that is this is the required flip-flop. So this is the input of the flip-flop and that input is connected to the combinational circuit and the output of this combinational circuit is connected to the input of actual flip-flop and this output of actual flip-flop is the required flip-flop's output. First one is SR flip-flop to JK flip-flop. So this is a very difficult portion. So before that, please go through the flip-flops in detail. So to convert SR flip-flop to JK flip-flop, so JK are the actual input and there will be a combinational circuit that we have to design, and this is our actual flip-flop SR, and then we will get the output and which will be the required flip-flops, that is JK's output. So for that we will write a truth table with JK, then QN plus 1 SR, where QN is the present state of flip-flop and QN plus 1 is the next state obtained. State obtained when the particular inputs J and K are applied. So there will, for J, K and QN, there will be 8 combinations. So consider J, K, Q, N and make a truth table with JK, QN as the inputs. That is, we have to get the input as JK. So first of all, design JK and QN with as the inputs and find corresponding Qn plus 1. That is the next state to be obtained while applying the inputs JK. We have to design the next output, that is Qn plus 1. We have to design, and then we have to design S and R inputs. That is the procedure. So let us write the truth table with JK and QN, that is present state of the flip-flop, as the inputs, as the combinations, 8 combinations, that is 0001, 00001, 010. So these are the 8 combinations for JK and QN. QN is the present state of flip-flop. So for each combinations of JK and QN, we have to find the corresponding QN plus 1. That is the next state to be obtained. We have to find, and that is 00. For JK inputs 00, the present output is 0. So what will be the JK inputs 00 output? That is, what will be the output for the input 00? That is no change. No change means here the present state is 0. That is no change here. Next state will be 0. Next is 00. 00 as the input of JK means no change to the output. That is, here the output is 1. That is no change means it is here 1. And next is 0 and 1. 0 and 1 to JK means the output will be 0. That is reset 0. It will not depend upon the present state. That is 0, 1 as the input to JK means the output will be 0. Next is 0, 1. So here also output will be 0. It will not depend upon the present state of the flip-flop. And next is 1, 0 to the JK input. 1, 0 to the JK input means the output will be 1. That is, it will not depend upon the present state of flip-flop. Next is again 1, 0. That is, output will be 1. Next is 1, 1. 1, 1 to JK input means the output will toggle. Toggle means output will change to the opposite state of the present output. That is, here it is 0. Then 1, 1 to JK means the output will toggle means 0 changes to 1. And here also 1, 1 to JK input, that is output toggles, that is here 1 changes to 0. So like this we have to complete the truth table. So this is the truth table. So we have to complete this truth table. Now we have to write the values for S and R corresponding to these Qn and Qn plus 1. That is, we have to write what values of S and R are required to change the state of the flip-flop from Qn to Qn plus 1. That is, we have to write what values of S and R are required to change the state of flip-flop from Qn to Qn plus 1. So this is the difficult portion while designing the conversion. That is here 0 0 0 0, that is 0 is the output. So here the next state to be obtained is 0. So to obtain output 0, what will be the values for S and R? So it may be 0 and 1, that is S and R. For S and R, S 0 and R 1, it will be, the output will be 0. And here there is no change, that is no change means 0 0 as the inputs. While giving 0 0 as the inputs, we will get the output as the previous output. So these are the two possible combinations for S and R. That means S value is 0 and R value is changing. So we can write 0 and don't care. So don't care means it may be 0 and 1. So we can write here 0 don't care. So this don't care is like this, that is the 0 output. This is the output to be obtained, and this 0 means S and R will be 0 and 1, and here no change, that means 0 and 0. So these are the two possible combinations. So we can write 0 don't care. Next is 1 1. So this 1 is the output to be obtained. To get to this 1, the possible combinations of S and R are 1 0, and here this is 1, that is no change. To obtain no change, here 0 0, that is S and, while giving S and R as the inputs 0 0, the output will not change. So here these are the possible combinations, that is here R is 0 always, S is changing. So we can write don't care and 0. Here also 0 0, 0 0 means we can write 0 don't care, and here 1 0. So this is the output to be obtained. To get this output, S and R will be 0 and 1, and here this is 1, that is different outputs. That means it will be like this, that is 0 and 1 here. S and R are 0 and 1, that is output is 0. Then here 0 1. 0 1 means this is the output to be obtained, that is 1. To get 1, the inputs will be 1 and 0, and here this is 0. So we can write 1 and 0 here, and here 1 1. 1 1 is don't care 0, and this will be always like this, that is for 0 0, the S and R inputs will be 0 and don't care, and for 1 1 it will be don't care 0, 0 1 0 it will be 0 1, 0 1 it will be 1 0. This is 0 and 1, that is the output to be obtained is 1. To get that, S and R will be 1 and 0, and for this, that is to get output 0, it will be 0 and 1. So this is the truth table for SR to JK flip-flop conversion. Now we have to design S and R, that is here this is the combinational circuit, that is which is the input to the S and R flip-flop. So we have to design this one, that is inputs to S and R we have to design. So this S and R we have to design. And here what will be the inputs? J, K and the present state of the flip-flop will be the input. So using K map, let us design S and R. So this is 8 combinations, that is the K map will be 3 variable K map with inputs J, K and Qn 0 0 0 1 1 1 1 0 0 1 0 1 2 3 4 5 6 7. So here first one is S. So let us design for S, the input S, that is 0 0 0, that is 0 0, then don't care 0 0, then 1 1, don't care, then 1 is 6 here. So for simplification, these two squares we can combine, that is here J and here the changing variable is K, so we can write Qn bar. Next is design for R. Again draw 3 variable K map. So the classes for the K map are also in this channel, so please go through it. Then J, K, Qn 0 0 0 1 1 1 1 0 0 1, then here 0 1 2 3 4 5 6 and 7. So next is R. Don't care 0 0, either we can write or no need to write here. Then don't care is here, don't care, then 1 0 0 0 1 here. So here we can combine these two squares. So R is equal to, for this one J is changing, so this K and Qn, K into Qn is the design for R. Now we have to draw the flip-flop, that is here S and R are the actual flip-flop, SR. So SR, then the inputs to S and R are, S is J, Qn bar. So this is Qn, then Qn bar. So the input to S is J into Qn bar. So there will be inputs J and K, J into Qn bar. So there will be AND gate, J Qn bar, that is here Qn bar. So this is the input to S, and R is K into Qn. So here also one AND gate, K into Qn. Qn is this one, and this is the input to R. So this is the logic diagram for SR flip-flop to JK flip-flop. So in this way we have to design each conversion. That is, this is the required flip-flop input and that is given to a combinational circuit, and the output of this combination circuit is given to the input of actual flip-flop. Then the output of this actual flip-flop will be the output of the required flip-flop. Thank you for watching the class. If you like the classes, please like, share with your friends and subscribe my channel.